All right, y'all, we're going to be looking at the angle of elevation and depression. All right, so the angle of elevation and the angle of depression are really just going to be talking about looking up and looking down. Now, the hard part is people typically draw the looking down angle incorrectly. So that's what we're going to focus on today. So the angle of elevation, you can see this picture over here, is just the idea of looking up. So if you've got a person and we look from where their eyes are at, right there, we got some eyes right there. We want to say that a person is always typically looking out. And then what they do is they look up. So the angle of elevation is simply the idea of looking out, then up. So out, then up is kind of a way I like to write it. So then you make sure that it is organized just like that. So a horizontal line, and then it goes up. Now the angle of depression is the exact same thing, but in the opposite direction. Okay, so we look at this person right here. We have a horizontal. It is out, then down. Okay, so I like to do it to where I put the then right there in the angle, so it makes a little bit more sense. That is your angle of depression. Okay, out, then down. Okay. So for example, if we were to look at a couple of example 1, example 2 here, it says the angle of elevation. So angle of elevation from the bottom of the lift, a ski lift, to the top of Snowbowl Mountain is 33 degrees. If a skier rides 1,000 feet on this lift to the top, what is the vertical distance between the bottom of the lift and the top? All right, so let's go ahead and make a nice little pretty picture here. We've got a mountain, okay? And that mountain peaks out. Hey, here's our mountain, okay? And this lift is going to be going up to the top. So we've got a lift right here. There's a person getting on it, okay? And they are going to ride to the top of the mountain. And we know that this lift is approximately 1,000 feet. Now, what it's saying is it's the angle of elevation. What that means is essentially out, then up. So out, then up, okay? And we have an angle of elevation. And what we are looking for is the height of this mountain. Well, the height of the mountain isn't at a diagonal, and it's not across. The height of the mountain is from the top straight down to where that person is standing. So how tall, what is the vertical distance between the bottom of the lift and the top? So now, we know that vertical distance is going to have a 90-degree angle with the horizontal. And so we're looking for the vertical distance, which is right over here. Okay. It also says the angle of elevation is 33 degrees. So angle of elevation out, then up 33 degrees. And now all we need to do, traditionally, I love to shade my angles. I come over here and I shade over here. I go across, there is the opposite. Okay, there is the hypotenuse because it's across from the 90 degrees, and this is the adjacent. So we have to first identify, okay, we're looking for the opposite. Well, remember, sine of an angle is opposite over hypotenuse. Tangent of an angle is opposite over adjacent. Okay, and cosine of an angle is adjacent over hypotenuse. Okay, and because we're looking for the opposite, we know that it cannot possibly be cosine in this case. We're looking for the opposite, so it must be either sine or tangent. Okay, and so we would set it up. We'd say we're looking for the opposite, and we have the hypotenuse. So that tells us we must be using sine. Looking for this, we have the hypotenuse, we have the angle. So I just come over and I say, okay, well, let's say sine of 33 equals to the opposite, which is x over 1,000. Just multiply by 1,000. Okay. X comes out and we get 1,000 times sine of 33. Now remember, we go off to Desmos. We do need to make sure that we are in degree mode. There it is. We are highlighted degree mode, and we just simply put in 1,000 times sine of 33. And you get 544. So x equals to 544 feet. Okay. That also tells us that that is the height or the of this mountain from the left. Okay? From the left. That's not the actual height of the mountain, just from where the left is at. Example 2 says the angle of depression of an aircraft carrier from an approaching airplane is 52 degrees. Okay, so let's say that we have got some water out there. We've got an aircraft carrier. There it is. It's sitting out there in the water. Okay, and we've got a plane that is flying through the air. Okay, and this plane is going in this direction. And what it says is the angle of depression of an aircraft carrier from an approaching plane is 52 degrees. So remember, angle of depression is out, then down, out, then down. Okay, so we go out, then we go down, just like that. Okay, except for this plane. Let me go ahead and just make sure I draw it a little bit better. This plane is going out, and then it looks down towards the aircraft carrier, and it says that it is at 52 degrees. So it is going in this direction. Now, if the plane is 700 feet above the level of the deck, so the deck is right here, and the plane is flying this direction and looking down at that aircraft carrier, and it is 700 feet above it. That means we have 700 feet is the altitude above it right there. So we've got that on as our vertical distance. Okay, how far away is the carrier? Now that's an interesting question. Let's go ahead and say it is going to, we have two questions. How far away is it? We can say horizontally, or we can say direct distance. Okay, let's go with direct distance in this case, direct distance. Let's say it is landing. So what we are saying is, well, how far until it lands? Well, that means it has to travel that distance directly down to it, okay? And since we know that, we can say, okay, well, we have got, let's go ahead and label our sides. So we have our angle that we know. This is the hypotenuse because it's straight across from the 90. And then we have the opposite, which is on the other side. And then we have the adjacent. Okay. Then what we do is we just go back through and we say, okay, we have opposite and we're looking for hypotenuse. So we come back through here and we say, okay, well, it cannot be the adjacent, cosine again, because we are not looking for the horizontal distance, which would be this right here. Let's see here, we have the opposite, so we could use tangent. We have the opposite, which means we could use sine, okay? But what are we looking for? We're looking for the hypotenuse. So once again, we come over here, we're looking for the hypotenuse. That's our question this time. We have the opposite, we have the angle, we must be using sine again, okay? And so I'm just gonna fill it in. I say sine of 52 equals to the opposite over hypotenuse, or 700 times x, and then let's multiply by x, okay? So let's cancel. We have x times the sine of 52 equals to 700. And then we're going to divide by sine of 52. Remember, traditionally, most of these problems with sine and cosine, we're going to multiply by the denominator to get these things started. Okay, so those cancel, x comes out. We just type in 700 divided by sine of 52. So let's go to Desmos, type it in. First thing I always do is make sure a wrench, and we go up to the settings, which is that little wrench. We go to degrees, and then I'm just going to type it in. 700 divided by sine of 52. And that gives us 888. So I come down here, I'm going to say that is 888. And then we were talking about feet. So we're 888 feet away from that aircraft carrier if you're in that plane. And remember, that is the direct distance to the aircraft carrier, not the horizontal distance. And we just distinguish the difference.